Once you're done, please put a dot. Okay. Come on, finish everyone quick. Now, if you look at this circuit, this is one more type of circuit which looks like the previous circuit. Just check. But over here, what happens is these two resistors have the same value and these two resistors have the same value. Over here, all five have a different value. Okay. But the circuit formation is the same. Over here, again, there are five resistors, but only three unique resistors where your first resistor will be this value common. Second resistor will be this value common, and in between, like a bridge, you'll have a third resistor. In that case, the equivalent resistance between A and B will be this formula. Make a note. Both are same circuit, but in this case, the resistors values are same. That is, two are same. Make a note.
So, sir, if you remember this is the previous formula, we can use that also, right?
You can use that also. In that, it will have common and it will cancel out. You can use that also.
Yeah. Okay.
Right. In fact, this is the condensed version of that formula.
Okay, sir.
Now look at the circuit of this kind, okay? Now they will say there is a bridge of resistors, okay? This is called a bridge of resistors, where, please look at the circuit carefully, where these resistors are all of the same value. These resistors are of the same value, and these are of the same value. That means R1, R2, R3, this thing into infinite. Again, R1, R2, R3, R1, R2, R3. And A and B will start from here, goes till infinity, comes back. Again, this case, we have to use the formula because solving up to infinity is not possible from circuit analysis. Therefore, for this kind of case, the equivalent resistance formula is this. Again, your errorless third formula. That is why if you look at your circuit questions in current, this type, and the type which we are doing right now, they look like theory, they look like problems, but it is only the substitution of a formula. This is actually square root, but they have written half, which is actually a square root. Therefore, make a note of this. But remember the notations. That is, please listen to me. This is R1, this is R2, this is R3. Don't think it is R1. 1 minute. Don't think it is R1, R2, R3. It is not like that. It is R1, R2, and R3 because in the formula substitution, it will make a difference. Okay, therefore, be very careful what you're writing as R1, what you're writing as R2, and what you're writing as R3. Okay, make a note.
Sir, they said that R3 goes to infinity. So does it mean on R1 and R2 go to infinity?
I cannot hear you.
They've said that R3 goes to infinity, right?
It is not R3 goes to infinity. This formation R1, R2, R3, there are infinite number of branches like this. That's
okay.
what it means.
Okay.
Okay, done.
Yes, sir.
Now, this formula, see here you have R1, R2, and R3. Okay. Now look at this circuit. We have only R1 and R2. Actually, if you go to see, we have only R1 and R3. But in they have written it as R2, where the bottom line, that is the B line, is empty. That is a straight wire, where you have only two resistors combination like this, which goes up to infinity. Then the formula changes to this. Actually, if you compare it with the previous diagram, this will be R3. But in this case, there are only two resistors. Therefore, they have taken R1, R2. Therefore, if this is multiplied into infinity, then what is the equivalent resistance? Answer is this. Make a note. Okay. Once done, please put a dot. Now, these four circuits, they look very difficult in the first place to see the formula, but it will be so helpful, especially when you solve circuit questions. So this is one type of circuit. You got a ready-made formula. This is a second kind of circuit. You got a ready-made formula. For this circuit, you got a formula, and for this, actually, these both are same. Actually, this is just a subset of the previous one, but anyway, you can remember them as four different circuits and four different formulas. Okay, so make a note and try to remember at least one every day. So till your exam, you'll remember the formula. This is 1, 2, 3, 4. Okay, these are the shortcut formula that you can use. Especially for the third and fourth diagram, there is no way you can actually solve up to infinity unless you know summation of infinite series and finite series. Instead of that, better you remember the formula itself. Okay. Now let us do some problems based on not this general circuit of current electricity. Before that, there is one more thing. This is actually a theory question. See here, if n identical cells are connected in loop, then the EMF between any 2 points is zero. Any 2 points means you take any two random points, but only EMF is zero. Don't get confused if in the question there's something else. And in this kind of thing, the cells should be identical, means their voltage, internal resistance, everything has to be the same. E comma small letter r means internal resistance as well as the EMF should be the same of all. And how many of our cells can be connected? That is n cells. EMF between any 2 points will be zero. Theory question, but can be asked into a problem where they might give you a dummy value of E and R, and instead of n, they might give you 10 to 20. Okay, so make a note of this as well.
So, sir, it won't matter that if there is like between 2 points which they've given, there are like 3 or 4 number of cells in between. Still the EMF will be zero between the 2 points.
Yes, yes. Provided they form a loop.
Okay.
Okay, next one. Try to solve this. Give me the answers and try to solve. Raju, I think C is right. Let's see.
So how will we take the impedance for inductor, for the inductor and the resistor, because we haven't
Mhm.
given the omega.
Okay, so I'll tell you, we have done this logic in EMI chapter. When the key K is closed, the initial current, as soon as the key is closed, we have done it in the chapter EMI. Initially, inductor behaves like an open circuit, and after some time, it behaves like a closed circuit. We have done it for an inductor. So as soon as the key is closed, this inductor will act like an open circuit. Open circuit means it will break the circuit. That means it is as good as current flows like this. That's it. This will not be considered at all because initial current. After some time, inductor will act like a closed circuit. That means the current will get divided. But they have asked us only initial. Therefore, the clue for you is the circuit we need to consider is only this. And then you have to find out resistance, and the resistance will be in series. Voltage will be here. And then you'll have to get the answer of current. Current is equal to voltage upon resistance. So it will become, what is the total voltage? 2. And what is the total resistance? 10 plus 20, which is 30. Therefore, the total thing will become 2 divided by 30, which is equal to 1 by 15 ampere. So answer will be C. Did you understand? The logic is at
Yes, sir.
the initial stage, inductor will not act. It'll be acting like a breaker. That means open circuit. So the current will go like this itself. Everyone understood? And in that case, the two resistance will be in series. Therefore, the total resistance will be 10 plus 20, which is 30. And the total voltage is 2. So it will become 2 by 30, which is 1 by 15. This is what is given over here. And the same logic, we have done some problems in EMI, where initially the inductor acts like a open switch, then acts like a closed switch. Exactly opposite with capacitor. Okay, exactly opposite with capacitor. Can I go to the next one, all of you?
Yes, sir.
Okay, this we'll have to find what is the current through the 2 kilo ohm resistance. But before that, can you at least tell me what is the total current in this circuit first? Rajvi, I think it will be 3. No, 9 will be correct. The total current, right, Rajvi? What you're giving me?
Yes,
The
sir.
answer for, yeah, the total current will be 9. If you're getting the total current, then get the current through the 2 kilo ohm resistor. That will be this. Just check. So can I say the total current in the circuit will be 9? That is correct. 2 people have given me the answer. Now the question is how to find the current through the 2 kilo ohm resistor. But everyone got the answer 9. Okay, because you know that these two are in series parallel with this. Again, these two in series, get the answer. you will get the answer as 9. Tell me if everyone is getting this much at least. The total current in the circuit is 9. Okay, getting it? Okay, now look at the answer. If you want, you can check step by step. They're just telling how to simplify the circuit, series, what is in parallel, and you get the answer 9. And that if you do into 1 by 3, because 3 ohm resistance is exactly in between dividing it, you'll get the answer as 3. But this is not the main thing because this keeps changing. Main thing is, are you getting this first? The total current in the circuit. That is equal to 9. First get that.
I didn't get the last part. The current should be low.
Current, actually, I'll tell you. This is called actually a divider circuit. Okay. So whenever anything in parallel is asked, okay, you can take the middle one itself. The total current divided by this will be the current passing through the other one. I'll tell you another
All
way
the
of
cases.
solving it with the direct formula. What is it, really?
In other cases also, we can take the middle one.
Middle
Like
one in the sense?
like if some different combination is given of the circuits of the resistances, we have to take the same the middle resistance.
Correct. But there is an easy way to solve this, and in future you will get a formula also. I'll tell you how this becomes this, okay, very easily, irrespective of the circuit. That is why right now I'm focusing on, are you getting the total current in the circuit as 9 milliampere? Are everyone getting this answer? Others, please confirm.
Yes, sir. Yes, sir.
Now, current through this is actually this into 1 by 3. This, you don't need to know it. I'll tell you an easier method. We will get a similar problem in the future, okay? 9 milliamp everyone is getting total current in the circuit. Okay. Now, this question is the basic question of resistor. Okay, basic question of resistor. Try to answer this. So where this current 1.2 ampere, it splits into three, I1, I2, and I3, and again combines over here. Okay, so we just want what is I2. Okay. Okay, I got one answer. See here, look at this. What logic they are using is voltage across all three branches are same. Like you know that when components are connected in parallel, current adds up, voltage remains constant. And if components are connected in series, voltage adds up, current remains constant. Remember our code word SV plus and PI plus. Now, these three are in parallel. Therefore, can I say voltage in this branch is equal to voltage in this branch is equal to voltage in this branch? Okay, that is V1 equal to V2 equal to V3. Now, what is the formula for voltage? Current into resistance equal to current into resistance is equal to current into resistance. Therefore, I get 10 I1 equal to 15 I2 is equal to 30 I3. How did I get this? Voltage in this is current into resistance, current into resistance, current into resistance. And since they are in parallel, all three are equal. Then you do one thing, get I1 and I3 both in terms of I2. Now from this equation, can I say I1 is equal to 1.5 I2 and I3 is half I2. Okay, we get I1 and I3 in terms of I2. That means instead of I1, I can substitute 1.5 I2. Instead of I3, I can substitute 1 by 2 I2. Therefore, I get all three in terms of I2. Now, from this circuit, can I say the total current I splits into three, I1 plus I2 plus I3. That is the total current I will split into I1 plus I2 plus I3. Total current I is 1.2. I know I1 in terms of I2. I2 will remain I2. I know I3 also in terms of I2. Therefore, can I say I will get the answer for I2 that way? Now, can you solve it? Why did I do everything in terms of I2? Because they have asked in the question, what is the value of I2? If they had asked what is the value of I1 or I3, I would have gone with that logic. Okay.
Done, sir.
Now this question, they can change it to find out I1 also. They can change it to find out I3 also. It is up to them. But in this case, they have asked I2. But in the exam, if they change to find I1 or I3, you should be able to get either way. In other words, you should be able to get all I1, I2, and I3. Okay, can we go to the next one? Start with this. Okay, I got one answer from Rajvi. Okay, others try to answer. You have to find the equivalent resistance between A and B. It is not between A and C that you take this in series, this and this. That would be between A and C. I have to find the equivalent resistance between A and B. Okay, be careful in solving. Okay, now see this. A and B. Okay, I will show you the previous screen. I'll show you this screen. Okay, now A and B, between them is 3 ohm. Just check. A and B, between them is 3 ohm. Just see the equivalent circuit. And between B and C is again 3 ohm. So what they have done is they have made it symmetrical. Between A and B, 3 ohm. Between B and C also 3 ohm. That means this is done. Okay. Now between A and C is 6 ohm. Correct. And between A and C on the top also is 6 ohm because these two are in series. Therefore, this also can be written as 6 ohm. Therefore, this will be my first equivalent circuit. So be careful where I am writing A, where I am writing B, where I am writing C. Now, since I want to find equivalent resistance between A and B, I will take 6 and 6 in parallel. That will become 3. Therefore, between A and C, my equivalent resistance will be 3. Between C and B is anyway 3. And between B and A was anyway 3. Now, these two are again 6 because 3 and 3. So it will become 6 and 3 in parallel. So answer will be 6 into 3 by 6 plus 3 equal to 2 ohm. I think Rajvi was the person who gave me the first answer. And Rajvi was the person who gave me the right answer. And I think Sonali gave me the answer after that. Virali, did you understand your mistake? And others, did you understand how
Yes,
do you
sir.
solve it? Rajvi, let me know if you have used the same logic.
Yes, sir.
Start with this. Anyone getting the answer?
Sir, I
Rajvi.
sent.
Okay, I think the answer should be positive because you're going from higher potential to a lower potential because the resistance is same 2, 3, 2, 3. Sonali, correct? So tell me what is the potential difference between this and this? See here, first of all, you should know that 2 ampere will get equally divided in these two branches as 1 ampere and 1 ampere because the total resistance is same. First point, you should know that. See here, 2 ohm, 3 ohm, 2 ohm, 3 ohm. That means the resistance is same upper branch and lower branch. Therefore, current 2 ampere will be equally divided as 1 ampere and 1 ampere. Therefore, I know the current in the branch. I know the resistance in the branch. Therefore, can I get the voltage in the branch? Yes, voltage over here will be 2, voltage over here will be 3. Therefore, A minus B will be the difference between 3 and 2. It will be 1 volt. Tell me if you are understanding the logic. Check and let me know if you're getting it, Raju.
Yes, sir, got it.
Sir,
Sonali, correct.
sir, can you just go to the diagram once again, please?
Hmm.
Over here, see, A is at 2 volt and B is at 3 volts. So we're going from lower potential to higher potential.
No, you don't have to do that. You have to do it mathematically. From these two equations, can I get VA minus VB? Can I
Yes,
get
sir.
from this two equation VA minus VB? So mathematically itself, -1 will go on the right hand side and become +1. You don't need the circuit for that. I got equation 1, I got equation 2. VD
Okay.
will cancel if I subtract. Then I get VA minus VB equal to 1. That way.
Okay, sir.
Sonali, let me know if I've used the same logic. Start with this. Nine resistors, each of 1 kilo ohm, are connected to a battery of 6 volt, as shown in the circuit below. What is the total current flowing in the circuit? Okay, Rajvi, Virali, Hetvi, you are all getting answer as D. Answer is correct. It is just an equivalent resistance circuit solving. Tell me, getting it with logic or getting it by fluke? All three of you, Rajvi, Virali, and Hetvi.
With logic.
With logic.
Okay. Now start with this. See here, in this diagram, can I steady state means after a long time. Steady state is exactly opposite of initial state. Steady state means after a considerable amount of time, what will happen to the capacitor you should see. Tell me what will happen to capacitor after a
Broken
considerable amount.
wires, so it will be 0. I mean,
Correct. That means can I say I can ignore this completely?
yeah.
Okay, then start. Rajvi, correct. Good.
So my
Others,
answer is not matching.
you'll get exact answer. You'll get exact answer. There are two things you need to find. So even if you get one thing, that means if you get the current, you'll get the answer actually.
Yeah, then
I'll show it to you. I'll show it to you. In the meantime, try to solve it.
is my answer correct?
Come again.
Is my answer correct? I've sent you the answer.
I'll check 1 minute. Rajvi is correct. Virali is correct. Hetvi is correct.
But sir, you said in steady state capacitor becomes 0. So how is the charge on capacitor?
I'm not going to charge. First, current will be 0. Charge will be a different logic because you have to find charge through a capacitor only, right? Because
Yeah.
charge Q equal to CV. So I'll show you. Look at this.
Okay, so the normal formula only.
Normal formula, yeah. Because otherwise you have to use Q equal to CV, capacitance formula itself. If you don't consider that branch, then the whole thing will go away.
Okay, sir.
Are you using the same formula and getting the answer or some other logic? Let me know, all of you.
No, the same logic.
Same
Same
logic.
logic. Okay, perfect. Okay, I will send this document and we will continue with tomorrow's class again. Rajvi, our doubts are pending. Either by tomorrow evening or by Wednesday, I'll close it out. Okay, Rajvi?
Yes, sir.
Okay.
So tomorrow what time?
I'm comfortable with this time. If you guys are comfortable, let me know.
We're comfortable with anything, sir.
Okay, perfect. I will put it on the group. You let me know if you're comfortable. Like I put for this class, I'll similarly put it for tomorrow. Let me know.
Okay, sir.
Okay. And Raju, I'll get back to you. Okay.
Yes, sir.
Okay. So thank you. I'll see you tomorrow.
Bye,
Bye.
sir. Thank you, sir.